Let's do some Python by example. If you like this content, don't forget to like, comment, and subscribe below. We're going to do another exercise from exercism.org. This exercise is called card games, and it's designed to teach us about lists and what we can do with lists. Let's take a look at the instructions and get going with the problem. The instructions say that this is about Elise. Elise is really looking forward to playing some poker and other card games during her upcoming trip to Vegas. Being a big fan of self-tracking, she wants to put together some small functions that will help her with tracking tasks and has asked for us to help her thinking through them. So the first thing we're going to do is this tracking poker rounds. Elise is especially fond of poker and wants to track how many rounds she plays and which rounds those are. Each round has its own number, and every table shows the round number currently being played. Elise chooses a table and sits down to play her first round. She plans on playing 3 rounds. So we're going to implement a function called getRounds that takes a current round number and returns a single list with that round and the next 2 round numbers. So I've got the code already downloaded for this assignment, and I've already run the test to prove that we don't have anything working yet. We're about to fix these tests related to the getRounds function. So we need to generate a list that looks like a set of 3 numbers in a row, and it's one number plus the 2 numbers after it. The natural thing to use here is probably the range operator in Python. So let's try that, and we're going to see that that doesn't immediately produce what we need. So we need to return a range, and the starting number for the range is going to be the round number itself. That's going to be the beginning point. A range takes a beginning and an end, and the end is a non-inclusive number. So if we need to include the next 2 numbers, we actually need to take the number and increment it by 3 in order to get all the way up to the value that we require to produce the right range. So let's say number plus 3. And then go and run the tests. Now, what we can see here is that we did not get the solution that we need, because what we have in the assertion is the rounds is looking for 0, 1, and 2, but we are providing this range object. Range is something that's meant to be iterated on, and if we need to have a list in this context, the simplest thing to do is wrap this range function call with a list construction. And that will take the range iteration and put it into a list that can be returned as a data structure. If we run PyTest again, the getRounds function should go away. And it does, so we got that right. Let's move on to the next function in the problem. So it now says, Elise played a few rounds at the first table, then took a break and played some more rounds at a second table, but ended up with a different list for each table. She wants to put the 2 lists together so she can track all of the poker rounds in the same place. Implement a function, concatenate rounds, that takes 2 lists and returns a single list consisting of all the rounds of the first list followed by all the rounds of the second list. So there are probably multiple ways to build this. The simplest way is to use the plus operator. So we should be able to do round 1 plus rounds 2. And the plus operator is going to generate a new list. It's not going to modify either rounds 1 or rounds 2, but it will take all of the elements from both of them and combine them, and it'll do it in the order specified by the problem. So if we do this, we can look for these concatenate rounds tests, and we'll know that all of these tests, that the function will work if all of these tests go away when we run PyTest again. And we see that they do, so we have successfully finished that function. Let's look at the next one. Talking about some of the prior poker rounds, another player remarks how similarly 2 of them played out. Elise is not sure if she played those rounds or not. We're going to implement a function called listContainsRounds, and it will be provided a list of rounds, so a set of numbers in a list, and the round number to look for. That's the 2 arguments, and we are going to return a Boolean of whether it's in the list or not. So you can see the examples here. We've got 27, 28, 29, 35, 36, and 29 is in this list, so we're going to return true. Looking at the second example, we've got 30, and it is not in this list of 5 numbers, so it returns false. Again, this exercise is all about list operations and very common list operations. And this is an incredibly common operation. It's checking for the existence of something, whether it contains it. And we do that with the in keyword. So we can say return number in rounds. And that checks if the number is in that list. So this should be these set of tests right here. List contains round. Those should be resolved by this check. And they are. So we can move on to the next part of the problem. Next is about averaging. So Elise wants to try out a new game called Black Joe. It's similar to Blackjack, where your goal is to have the cards in your hand add up to a target value. But in Black Joe, the goal is to get the average of the card values to be 7. The average can be found by summing up all the card values and then dividing that sum by the number of cards in the hand. So it's a classic math averaging function. So if we have this example of 5, 6, and 7, we're going to return a 6 floating value. And the reason this is a floating number is that averages, of course, can have a partial portion. They don't have to be necessarily integer values. And so we are going to be able to do that as well. All right, so let's look at how that's going to be done. The first thing that we can use is the sum function. This is a built-in function to Python that takes an iterable or some kind of list-like structure and produces the sum of all of that. So if we provide the hand, then we get the numerator of an average. The denominator of the average is the number of items in that list, which we can get from the length function, which is len in Python. So we should be able to do sum divided by length, and that should give us our numeric average. So the card average is these 4 tests here. We should see those drop out when we run the tests. And they did. So we can move on to the next piece of the problem. Here we start getting to more interesting functions that have more depth to them. And we'll see all of these rules that we're trying to do. In Black Joe, speed is important. Elise is going to try and find a faster way of finding the average. She has thought of 2 ways of getting an average-like number. So we want to take the average of the first and last number in the hand. And the other way that she's devised is using the median, the middle card of the hand. So what is this function looking for? We're going to implement this function that given a hand, which is a list of values of the cards in the hand, we return true. Now this is the important part right here. If either one or both of the above named strategies result in a number equal to the actual average. Okay. So the first thing we know that we're going to need is the actual average. And rather than recalculate this, we already have a function directly above. So let's take that, and we're going to store this in a variable locally. We'll call it card average, and it's going to take the same kind of hand that we got in that same function above. So now we have this average. So we need to know that the average is equal to one or the other. So the rough structure is going to be the average is equal to something here, or it's going to be equal to something else. So those are the 2 things that we need to fill in. So the first one is an average that is built by taking the first number and the last number from the list and then averaging those 2 things. So it's going to be getting a value from the beginning of the list, getting a value from the end of the list, adding them together, and then dividing that by 2. So let's do that. Since it's the ends of the list, let's call it the ends average as our variable. That seems like a decent name. So we've got the ends average. And how do we get that? So we're going to get the 2 values. So we're going to use an index operation to look into the list. Those are the square brackets in Python. And then we need to divide that result by 2. But since we need to add them together, and precedence of operations matters, you know, your classic, please excuse my dear Aunt Sally, we need to do the addition first, but division is going to want to happen first. So we're going to wrap the addition in parentheses so that we make sure that that operation happens in the right order. So let's take the first value from the hand. That one's pretty easy if you've come from other languages that have lists and array-like structures. But how do you get the last value? Many languages might have you do something like this, where you take the length of the hand and then you do a subtraction of 1 on that in order to get that value. And while that works, it is not the nicest way in Python. Python includes this special form of getting the end of a list, and that is through negative indexing. So we could do this, but I'm not going to do that. I'm instead going to use -1, and that's Python's shorthand way of saying go to the end of the list and start getting a value from there. We've got the beginning value and the end value, and then we can divide that by 2, and that's going to give our average. So that's going to be the first set of question marks that we're going to remove here as the ends average. Okay, let's look at the other kind of average-like thing that it wanted and see how we get that. So the second way of doing this is by getting the median, or the middle card of the hand. There is a note here that is worth calling out, which will actually make our solution easier. It says the length of all hands are odd, so we can trust that it's going to be 3 or 5 or 7 or something like that to get our set of values and find an actual median, versus having like an even length and then the median being something that's split between 2 values. They're just trying to simplify the problem for us. So how can we get that middle value? We can do that by calculating an index. So if we have a list of 5, we know that the third element is going to be that median value, and we need to get the index of that. In Python, the index is 0 based, so the first element in a list is 0, and so the third element in a list would be 2. So now we can think about this and we can figure out the solution by just taking that knowledge that we have. So let's create a variable called median index. And we know that the length of the hand is going to be the number that we have to use to do our calculation. So that's going to be 5. If we do an integer division, in other words, we do a division where we throw away the remainder, and it does a truncation in Python, then we could have 5 divide integer division by 2 to cut that in half. And so instead of returning a 2.5, it'll be a 2. Because that's what integer division does. That's what this double slash is for. And if you think about it, that is exactly the number that we need for the hand value of 5. It's going to be the third element. Let's think about a different value just to test it against some other stuff. If we have 7, then and we do the integer division divide by 2, we're going to get not 3.5, but we're going to get 3, which would be the fourth value in the list, and that would be the median of a list of 7. So we have our median index. So what we need to do is then access that value by that median index. And that should pull out the right value that we want from the list and be able to compare it to the real average. All right, let's check if we're right on the solution. So we've got this bunch of tests right here. The approximate average is average functions. And let's run the tests and see, good, we got rid of them. So we've passed those tests and we're closer to having a final solution. Let's look at the next function and see what's in store for us. More averaging techniques. So it says, intrigued by the results of her averaging experiment, Elise is wondering if taking the average of the cards at the even positions versus the average of the cards at the odd positions would give the same results. We've got another test function that is going to take a hand again, and it returns a Boolean if the average of the cards at the indexes is the same as the average at the even indexes, is the same as the average of cards at the odd indexes. So here's the tricky part of this problem. We need essentially to take a hand list, which could have some unknown number of elements. We need to pull out all the even ones and pull out all the odd ones and calculate an average from those and an average from those and see what we get. So how do we do that? There are a bunch of ways to do that, but we're going to use something called slicing. Slicing is a way of taking a portion of a range. Now, most of the time when you work with Python, a slice would take a continuous range. So you might take from the beginning of a list just to a few spaces along and grab that first chunk. Maybe you'll take from a portion in the middle of the list all the way to the end, and that's a very natural thing to do. There is this one cool little attribute of slices that we're actually going to take advantage of here. So if you look at the slice syntax, which we'll get to in a second, the third way to do things is to define the step that you want to take. So most of the time in a continuous set, you take a slice and it's moving one step at a time. So it's essentially taking every element in order. But you can tell Python to take not every element. You can tell it to skip things, which will be perfect for doing evens and odds. So I'll write out some solution here and then define or describe what we're seeing so you have a good sense of this. So we want to check if two things have the same average. So we're going to use the card average from above. And we're going to use the hand in a way, and we're going to do as well a card average of the other hand, or the same hand. So we're going to need to take a slice of both of these. So now it's time for the slice syntax part. So we want let's start with the odds. And so the odds are going to be at the even indices, ironically. So it's going to be 0 and 2 and 4 and so on like that. So we want to take a slice that it starts at 0, and it's going to go to the end of the list. Normally, you could leave it like this, and this would say, this is a syntax way of saying, give me everything from 0 and onward, which is essentially the same as the list. But remember, we want to be able to skip elements. And in order to do that, we can use the step, which you only get from introducing another colon and then putting a step after that. So the slice syntax is the element to start with. There could be a number here. Let's just put 4 for a second to give you an idea that there could be something else there. That would be the element to end with, non-inclusive. So this current slice syntax is a way of saying, give me elements 0, 1, 2, and 3. That's what it's trying to say here. And then you can put the step at the end. If we want to go every other, we could put a step number of 2. Now, we don't want to have any kind of end on this, so we're going to take out the end number. So that leaves us with this 0, : 2 syntax. It looks a little funky, but that is doing a slice that is taking all of the odd elements of a list. Similarly, for the even numbers, it's the same kind of idea. All we have to do differently is move to the even numbers, the starting position, which is, again, ironically, the odd indices of the list. So it's the same concept. We start at 1, and if we wanted to get 3 and 5 and 7, we would do a step by 2. And so now we've got the card average of all of the odd numbers, or all of the odd values in the hand, and the card average of all of the even values in the hand. Let's see if we got that solution right. We've got this average is even is average odd tests right there. And whoops, I forgot a closing square bracket, so that's my fault. Let's try it again. Good. Okay, they went away. That was good. It was just a typo on my part. All right, finally, maybe double last is the last function we're going to look at. And so we've got this section 7 here. It says bonus round rules. Every 11th hand in Black Joe is a bonus hand with a bonus rule. If the last card you draw is a jack, you double its value. So we're going to implement a function called maybe double last that takes a hand, again, which will be a list, that takes a hand and checks if the last card is a jack, which they're telling us is defined as a numeric 11 value. If the last card is a jack, we want to double its value before returning the hand. So we want to modify the hand, not create a copy, but actually modify the list that's provided. So I think we can have a pretty good handle of what to do here, especially when we keep in mind that we learned about this negative index syntax that earlier will give you the last element. So we want to check if the last value is an 11. So we take the hand and we do the negative index of -1, and we check if it's 11. If it is, we want to modify it to be double its value. So again, hand -1, we want to change its value. So we're going to do the multiply equal, which is saying take the value of itself and multiply it by something, and then multiply that by 2, which is equivalent. You could write this another way. We could do this hand -1, hand -1 times 2 times 2. So that's the same way, but this is the shorthand way of doing the same thing. So we're going to put it like this. And then finally, the thing we need to do is return the hand back now that it's been modified. So if we run the test again, we see that everything passes. So we have successfully done all of the card game rules. And before we finish up, let's check out some community solutions. Let's start by checking out Baba Hop's solution and see what this user did. For get rounds, they were actually far more explicit than I was. They created an actual list and then added a 1 and a 2. So they didn't use the range operator at all. It does exactly the same thing as we did, except it does it in a different way. That's pretty cool. For concatenation, they use the extends method on the rounds. I'm not actually crazy about the solution because what this is actually doing is modifying the input argument and actually changing that. So it's mutating state on the input, which could have weird side effects if this was called multiple times, and could have ramifications that you didn't anticipate. So I guess if you're aware that it's doing that changing the state of the variables, you could go that route, but it's not a solution I would recommend. Also, it's doing something that's fairly non-standard for Python here, where it's got a semicolon. While you can use semicolons in Python and it will do the desired effect of effectively creating one line, it's usually not considered great form. So, kudos to them for getting the right solution, but maybe -1 for style points, I guess. Their list contains solution is exactly the simplest thing you would expect. Let's move on to the next one. This one caught me off guard. So this is the mean function, and if you look at the top, you can see that this comes from a statistics module. The statistics module is actually part of the Python standard library. This is not a new addition anymore, although it looks like it came about in Python 3.4. So there is cool math stuff you can do there. I was unaware that this library existed, so props to them for using the standard library to not reinvent the wheel. So even though we did something correct by calculating with the sum and the length, I think it is actually probably better to do what they did and just use the standard library because it's very clear on the function of that. What they did with this one-liner here is a working solution. It's very similar to what we did. You can see that it has the card average, which this person called meanie, and then it has exactly what we did, hand 0 and hand -1 divided by 2, or meanie with hand with the length so it kind of just collapsed all the stuff that we did in a few lines down into a single line. It used something additionally, which is it's a newer feature of Python. It was introduced a few versions ago called the walrus operator, which effectively allows you to define a variable in a single expression and let you use it in that same expression, which is why defining it here meant that it could be used over here. Instead, I think I pulled this out into a variable in a line on its own. It's effectively the same thing. I think, again, I'm not really crazy about this in terms of the length of the line and how much is going on in a single line. So it's almost like they're going for code golf here, which is fine. Maybe that's what they're trying to do. If you're trying to communicate with teammates, I probably wouldn't recommend that approach. All right, so looking at the average, it's pretty much exactly what we did. The thing that is noteworthy to call out here, though, is that you can exclude the beginning slice number. So we included a 0 to be very explicit about it, but it's just as valid to leave that 0 out because Python will default to going to 0 when doing a slice. So that is something worth noting, and that's why this works just as well as what we did. And then finally, they're using the walrus operator again here just so that they don't have to redo the calculation, but it's effectively pulling the last value into a variable and then doing that multiplication. So where we did the star equals operator to bypass that in kind of the longer form way, this is another way to be a little bit explicit about what that value was, give it a name so that that's meaningful, and do that multiplication and then stuff it back into the list. So it's accomplishing the same way we did it in a slightly different notation. And again, this walrus operator is, and it's called a walrus because it's meant to look like eyes and a pair of tusks, like if you can turn your head sideways, that's what that is. It's something I don't see all the time, and if you're confused by it, don't worry about it. You can just put stuff into a local variable if you want, and it would be just as good of a solution. So nice job, BabaHop. I think there were some interesting lessons to learn from this. Let's look at one more. This is Sophia Shee's solution, and let's check out what they did. So they followed BabaHop's path of taking a list and taking advantage of they knew exactly how many items were supposed to return, so they skipped out on the use of range. That's a nice, simple solution. I like it. The concatenation is what we did using the plus operator, which is, I think, a way that doesn't include the side effects, so I think that's a good thing. They have the same way of checking for a number in the list, which is a good way to go about it. They did the average calculation like we did, so they didn't know about the statistics module either, or they chose not to use it, one or the other. So exactly the same there. Their solution for checking the card average does not create a local variable, so there's the cost of calling card average twice, so there's a little bit of wasted computation in there. But if you look at what they're doing, it's the same thing. It's checking the length of the hand minus 1 divided by 2, although we just concluded that you don't need to do this minus 1 when you're doing that integer division. That's what the integer division is actually getting for you. It's tossing away the remaining value, so that was probably unnecessary to do the minus 1 right there. And then on the other side, they are checking the card average. Oh, that's clever. They created a list of the two values and passed it to card average rather than doing the addition and division by 2 right there. So interesting way to take advantage of the functions that were there. And then finally, or not finally, they have the card average with the exact same slicing notation as we saw in the previous community solution. So good job. And at the end, they have something that's similar to what we did with the way we implemented maybe double last, but I'm not sure I'm wild about this. And the reason why is because they're using a modulo 11. I think this happens to work because of the domain of the problem, which is presumably a set of cards going from ace at 1, 2 through 10, and then if it was jack, queen, king, you'd have 11, 12, 13. So this works assuming that you keep it to that 13 or less. I think where it gets a little funky to me is, imagine there was a value in here of 22. This would also result to a value of 0, and then it would create a 22 times 2, which would be 44. It just doesn't make sense in that context. So if you stay within the constraints of the domain, it's fine, but I think the more natural thing is to, instead of doing a modulo and then checking if it's equal to 0, just check if it's equal to 11. I think that's the simpler way to go about it. Same result though, so it doesn't really matter. It gets the right answer in the end, but that's just my observation of be careful when using modulo. It can be used on many values of a number and could have multiple things that could be the right answer here. So those are two solutions that took the same problem that we had and did it in a slightly different way. Hopefully you learned something from these users as well. I think they both did a pretty good job. If you like the content, please be sure to like, comment, and subscribe below. Thanks for checking it out.